It turns out that the hazard function is so important that we have 4 examples of drawing hazard functions in particular applications. Here's the first one. Draw the hazard function for an automobile whose preventive maintenance includes only gasoline refills and oil changes. The automobile fails when it can no longer move. Include units on both axes. So we start out by putting time on the horizontal axis, and we're trying to draw a hazard function, so that'll go on the vertical axis. To keep the units in check here, I'm going to define time for the automobile in terms of thousands of miles. Now remember, we're only doing gasoline refills and oil changes. We're not changing out tires or the ignition system. We're not putting in a new starter, nothing else. So there's a lot of different ways this thing can fail. For the hazard function, there is going to be a little bit of risk for a brand new car, and then it's going to go for a long while. And then after 40, 50, 60,000 miles, you're going to be looking at possibly a tire going out. So maybe this point right here, maybe that's 40,000 miles where you're going to get into trouble on a brand new car. Now the next question is, what are the units along this vertical axis? And let's put a tick mark in here about where this hazard function is at its lowest point. If you are typically taking this automobile in every 1,000 miles for a particular problem, you would put a 1 here. So that's 1 failure per 1,000 miles. If you say, no, I don't take my car in that often, I bring it in every 2,000 miles, then this would be a 0.5. If you say, no, I take it in every 10,000 miles to have something replaced, then it would be a 0.1. So the units along that vertical axis are very much dependent on how reliable your car is. Is it a Lamborghini, which requires a lot of fine-tuning? Then the hazard function would be higher. If it was the typical sedan and from a very reliable company, then it would be significantly lower. So that's the first example, hazard function for an automobile. Second one says, draw the hazard function for a window pane in this classroom. The window pane fails when it breaks. Include the units on both axes. So once again, here is time. We are drawing a hazard function. And let's include as units here, let's go with years. And you don't see these window panes breaking very often, so let's go with 100 years on the window pane. Well, you might have a little bit of increased hazard function at first, and that's to account for the fact that it may not be installed properly. And then as time goes on, there's going to be a little more risk, and it may look something like this. So we're back to the bathtub shape again. But if this window pane in the classroom happens to be on the first floor, it could very well get taken out by a snowball fight, which means there's got to be more risk in the winter and less risk in the summer, which means the same hazard function would do a little bit of this. More risk in the winter, and that's when the hazard function is higher. Less risk in the summer, and the hazard function is lower. And that's if it's on the first floor. So you might get something that looks like that. You'd have 100 of those ups and downs in the 100 years. Now the last question is, what should be the units on the vertical axis here? A window pane breaking, and that's what we're defining to be failure, not just leaking around the edges, but actually breaking. That's very unlikely. So you're going to have some type of small value here for the units on the vertical axis. And 0.01 says that this is very unlikely to happen in a particular year. So that's the second example. Now to the third example. Draw the hazard function for a new computer program which is being run daily. Program fails when it does not run properly. Include units. So this time is defined for us. This is the run number. And unlike the previous two examples where time was measured continuously, this time is being measured in a discrete fashion. So this is run number 1, 2, 3, 4, 5, 6, 7, 8, etc. And at this point, the hazard function is going to be the probability of it failing on the first run. If I were the programmer, this would be very high. Let's put a high probability out there, maybe 0.2. And then if I get through that first run, then the next day when I run it, it will be significantly lower, and you just get a little bit more confidence in the program each time you run it, so the conditional probability or the failure rate will come down as time goes on. So there is the third hazard function, which is different in that time is discrete. In most reliability applications, time will be run continuously. Fourth example. This one's significantly more complicated than the first three. Draw the hazard function for a drill press whose preventive maintenance includes changing the drill bit daily at 8 a.m. The drill press is used during working hours, and that's between 8 a.m. and 5 p.m. Include units on both axes. So in this particular case, we will have time, and since we're getting 8 a.m. and 5 a.m. up here, I think we can easily say the time should be measured in hours. And of course that means that our vertical axes on the hazard function will be failures per hour. Now there's a problem in that we only run from 8 to 5, which means from 5 p.m. all the way down to 8 a.m. you are not going to have a failure. So what I'm going to do is say this first little piece here, the first chunk of time, is where you are actually using the drill press, and then we're going to have a hazard function of 0 here for the drill press because it can't fail from 5 p.m. to 8 a.m. Then we'll have another chunk where it is being used, and then 0 risk here, and then there's the day number 3, 0 risk here, day number 4, 0 risk, etc. Now we have to figure out what the hazard function is during the working times. Well, it's reasonable if this drill press is being used continually to say there's a chance that changing the drill bit was done inappropriately, so there's going to be a little bit of a dip here in the initial hazard function, and then maybe as the day goes on it gets a little bit higher. Then on the next day it might look like this. Next day might look like this, and the next day it might look like this. You'll notice that I'm putting an increase here because the only preventive maintenance we're doing is changing the drill bit, and we're not looking at the drill press, which means there's an increased risk over time. Now the units here I am not going to pin down. You could put something in here, but this depends a whole lot on all the factors associated with this drill press. Is it in an air-conditioned environment? Is it in an unconditioned environment? Is the turning rate of the drill bit high or is it low? Is the feed rate high or is it low? Are you drilling wax or are you drilling tungsten? So all of those are going to factor into what the units will be over here. Once you get those pinned down, then you can indicate what the units will be.